All right. Hey, what's up, guys? This is an example problem. It's on your homework this weekend, number 12 on page 20. Now, I was hoping we would do this in class because this is a proof that has to do with, we see angles here, these angles. No, we don't see angles. So they don't have to do with angles. They have to do with segments and the segment lengths, which come up on a couple other problems. Okay. The examples we did in class on Friday had to do with angles. So let's take a quick look at this one that you have to do. Okay. So given ST is equal to Rn. Okay, so this is actually one thing that they didn't mark out for us because that's this whole segment here. ST here, that distance here is, and I'll just put 2 tick marks down so we remember it, is equal to Rn, which is the length of segment Rn. Sorry, it's all squiggly like that. It's hard for me to type or draw on my computer. And then also here, they marked this out for us, that segment IT is the same length as segment RU. So that's our given premises. And what I have to prove is if SI is the same length as UN. Okay, and looking at this here, like logically kind of looking at this here, my whole segment is congruent to my whole segment. Those lengths are the same. And this part segment is the same length as this part segment here. So really, I'm probably going to use subtraction at some point. Okay, this whole segment's congruent to this whole segment. These are the same lengths. I'm going to subtract these two, and then that should be enough to show that SI is equal to UN, which is my goal. This is what I'm trying to prove. Okay, so let's go ahead and do that right now. First things first, let's see how they started the proof here. Okay, so they did ST is equal to RN. They put that in there as the very first step. Okay, so what justifies that ST is equal to Rn? That's what you want to ask yourself. I'm writing an equation. What justifies that? Why am I allowed to do that? And the reason is, and I hope you all get it here, is given. Given. And I'm not on my stylus right now, so it's going to take me a while to write it on out. There, given. Okay, given premise. Okay, so we've used this given premise, and later in the proof, we'll probably use a different given premise. That's kind of how it works, right? We're going to use all these given premises and information we get from the diagram to eventually get to what we're trying to prove, that SI has to equal UN. Okay, next statement here. All right, so this is another thing. Like we had a different equation. Is this equation here, number 2, is it given to us? Okay, is it given to us? No, it wasn't given to us. I don't see SI plus IT anywhere in the given. I don't see RU plus UN anywhere in the given. So something might have happened. I also only have one equation here in step number 1. So this isn't an addition property of equality. Why? Well, ST equals RN, that's just one equation. Addition property of equality has me take one equation and add it to another equation. Okay, so what must be the case here is that we got this information from the diagram. Okay, remember, when you're given information, you can't really build upon it. You get information from the diagram. And where's the diagram again? The diagram's right here. Upper right corner. Okay, so what do we pull? What's something that we can, what's an equation we're allowed to set up just by looking at this diagram here? Okay, well, I think you'll hopefully see it here. SI plus IT, what does it equal? The length of a segment SI plus the length of a segment IT equals, well, the length of segment ST. Part plus part equals whole. Okay, so I'm going to go ahead and write that in with this pen. This is the pen that I should have been writing in left. What goes here is going to be ST. And what goes here, RU plus UN, is RN. Okay, and the reason for that, well, what's our part plus part equals whole rule that we follow? Okay, postulate 2. Okay, look at that, postulate 2, which is the segment addition postulate. Segment add postulate, to abbreviate it. Okay, so hopefully you write it down, and that's what you got. All right, Hector. I'll just pause this here. All right, let's finish this bad boy up here. Okay, so we have these statements being said here now, right? Remember, a proof, as I explained to you in class on Friday, is a chain of reasoning. We want to look to see what our previous equations were and how we can change them to say new things. Okay, so here I see SI plus IT. I also see it again in statement number 3. I see RU plus UN. I also see it in statement number 3. So what happened? what justifies this? Okay, I have my given premise, ST equals Rn. I got this from the segmentation postulate. How can I use the previous statement, statement 1, statement 2, to arrive at this right here? Okay, and maybe you saw it, maybe you didn't. This is a harder one to see. Okay, but I have ST right here, and what do I know about ST? E equals SI plus IT. I can pop it in there to the left side of that equation. Okay, what do I know about Rn? Okay, Rn is here, but Rn, length Rn that is, it equals length Ru plus length Un. So I can pop that into the right side of the equation there, okay? So what's happening here is I have replaced, in step number 1, I have replaced ST with SI plus IT. This right here. That's now on the left side of this equation here. And I've replaced Rn with Ru plus Un. That's on the right side of this equation here now. So what justifies this? Well, I'm substituting. This is the substitution property of equality. So I got substitution here. Substitution. Thank you for watching this. It takes a little while to write this out. All right, we're almost there. I think most people, well, actually, this isn't reflexive. I thought this was a thing equal to itself. This is IT equal to RU. How do we know that? How do we know that? Well, check it out here. This was a given premise. They didn't list all their givens right away. And that's okay. Like, they wanted to say, use this. They're listing it now. Okay, listing it in here. So this is actually given. This is another given. You don't have to list all your givens right away. What they're doing here is they're listing this given because they want to make it easier to figure out how we can get from statement 3 to my final answer. Okay, SI equals UN. Okay, let's check it out here. This is what I'm trying to prove. This is what I'm intending upon proving here, that length SI, this part length here, is length this part over here. Okay, sort of an extension of the segment addition postulate. Okay, so how do we get there? Well, what have we said so far? Okay, we've said SI plus IT in step 3 equals RU plus UN. What can I do? Well, it turns out I can subtract. Okay, the thing that I know is equal to RU, I can subtract IT from this side to change the equation as long as I subtract RU from this side. Boom, boom. So that's subtraction, right? Subtraction, okay? So my last step is the subtraction POE, property of equality. And now, right, if I subtract IT and RU from both those sides, I'm just left with SI equaling UN. And we did it. You did it, or I did it. But hopefully you can do it too, and you understand where it comes from, because that is what we intended to prove when we set upon out our mission in proving this fact here, okay? And I'll highlight it in green. I know it gets messy. That right there was my proof statement, and now I've gotten there in step 5. What can I write? What can I write to pat myself on the back? That's right. I can write QED, my friends. QED, quod eris demonstrum. We've demonstrated what we set out to prove, and that example's done. Message me if you have any questions. These will be little puzzles that we'll work on for the next few days, and take it from there. Have a great weekend. Bye.